Fifth grade lesson 2.4 is partial quotients, just kind of re-breaking down the division algorithm again for why what's happening is happening, and then we will go into using the algorithm again in the next lesson, so this should be a quick one. Our essential question is, how can you use partial quotients to divide by two-digit divisors? Let's unlock the problem. People in the United States eat about 23 pounds of pizza per person every year. That's it? So there I've highlighted that. It actually does sound like a lot, and I think I do eat that much pizza. If you ate that much pizza each year, how many years would it take you to eat 775 pounds of pizza? Let's highlight that too. Rewrite in one sentence the problem you're asked to solve. I'm asked to solve how much years, how many years to eat 775 pounds, lbs, of pizza, doing 23 pounds lbs of pizza per year. And so if I'm splitting this 775 pounds of pizza into how much I'd eat in a year, which is 23 pounds per year, then splitting it equally is division. So we're going to divide 775 divided by 23. So partial quotients is just is a way you can kind of get around and do things in your head sometimes. Sometimes you can really do it in your head. Subtract multiples of the divisor from the dividend until the remaining number is less than the multiple. The easiest partial quotients to use are multiples of 10, because everything times 10 just puts a 0 on the end. So that's what we're going to do here. We have 775 divided by 23. 23 is our divisor. How many, if we do 10 23s, that's going to be 23 times 10 is 230. And when we subtract that, we're left with 545. I can still fit another 230 into this new dividend. So I'm going to do that again. 10 times 23 is 230. And I end up with 315. I can do another one. 10 times 23 is 230. And I'm left with 85. I can't do another times 10, but I could do 23 times maybe times 2, maybe 3. And if I'm not sure, I'll just times 2, 23 times 2. So I haven't been putting these over here. 10 times 10 times 10 times, now 23 twice this time. 23 times 2 I could do in my head, 46. So that's why I chose that. Then I'm subtracting 39. I can do that 23 one more time. And I end up with 15 left. So altogether, when you put all of those times that I multiplied 23 times something in order to cover all of this ground, I just now add that together. It was 10, 20, 30, 32, 33 times that I did that. And I ended up with a remainder of 15 left. So it would take you more than 33 years to eat 775 pounds of pizza. That's a lot of pizza. Let's look at the other example. It's more pizza. That makes me happy. Miles is helping his father with the supply order for his pizza shop. For next week, the shop will need 1,450 ounces of mozzarella cheese. Ooh, that's a lot of cheese. Each package of cheese weighs 32 ounces. Complete Miles' work to find how many packages of mozzarella cheese he needs to order. And so we're just going to kind of slowly pull out multiples of 32 from here, rather than try and figure out 32 times what and use the algorithm like we're going to use. And then what might happen is some of you might prefer it this way over the way that we're going to use. So it's good for you to see this going on. So we're going to do the 32 as the divisor, and we'll do 32 times 10 because that's easy to do, and we get 320. Subtract, that gave us 1,130, so there's 10 times there. Let's do 10 times again, and of course it gives me 320. You subtract, you get 810. And then we go ahead, because 810, we could still fit some 32s in there, quite a bit of them. We do it again, 320. We're left with 490. Oopsie. 490, we still can fit 320 into that, so we'll do times 10. And that gives us 320. When we subtract now, it's 170, so I can't do it times 10, but maybe 32 times, I don't know, 5, maybe? I don't know. Well, 32, they ended up getting 160 there, so 32 times 5, let's see what that is. 1560, yeah, 5. And that gave me 160. Subtract that and you get 10 left over. So that was a 5. So how many times did I have to multiply 32 times itself in order to cover all that ground? 10, 20, 30, 45 times. And I was left with a remainder of 10. So he needs to order, well, he's not going to be able to order a remaining amount. So we're just going to have to order a little bit extra. So 45 and a little extra. So let's just order 46 packages of mozzarella cheese. On this one, they say use different partial quotients to solve the problem above. I like using the 10 because for partial quotients because it's just easy to multiply. I guess I could use times 20 because I know it's going to be a lot. And times 20 would mean the 3 is times 2, that's 6. 2 is times 2 is 4, and with the 0 on the end from the 20. So we could do that, I guess. If it were me, I'd just be sticking with the 10s and doing it several times. But if this makes sense to you, we could do that. We're going to say 32 times 20, which equals 640. So we have the 20 there. We get 7, 8, 9, 10, 11, 12, 13, 14, 810 left, which I can fit 640 in again. So now that I know that 20 times 32 is exactly 640, I can use that 20 again. And I'm getting 5, 6, 7, 8, 9, 10, 11, 170. And so now I can't even do times 10 to that. That's going to be too much. For this one, I would be doing maybe times 2. I know we know it from before, but realistically, I only did it that way because, and kind of had to figure it out to the side because they already had it set in there. For me, I don't know 32 times 5 in my head, and my goal with this is trying to do a lot of it in my head or real quick on paper. So that would be 64. And we end up with 106. And so I could do that again. That is 64. I end up with 42. And I can do that 32 one more time. And I get 10 left over. So altogether, it took me 20, 40, 41, 42, 43, 44, 45 times. And there was a remainder of 10. So they're just wanting you to see that if you're doing partial quotients, if you can see a higher way to multiply it, if you've got big numbers so you don't have a big long row, you can do that too. Or here I went higher, but this one I went smaller than the other one because these were numbers I was calculating in my head, so I didn't have to go off to the side and calculate them out. So the idea is that use the numbers that make sense to you that you're calculating out. I guess there's multiple ways you can get to the answer. All right, I'm going to go ahead. They want me to divide using partial quotients, and you've already heard me say I prefer to use 10 because it's just super fast in my brain to do. So I will do 18 times 10 because that's going to be 180. I can do that. 18 times 10. So there's the 10 used once, so I'm putting that off to the side. That gives me 180, leaving me with 9, 10, 11, 12, 13, 14, 6, 4, 468. So I can do that again, and that's another 10 that I've used off to the side. That doesn't mean that that equals 10, it's just off to the side. 180, 10 times 18, 180. 8, 9, 10, 11, 12, 13, 14, 15, 16, and 3 minus 1 is 2. I can get 180 in there again, so I will go again. 180. And I cannot get 180 in there again, so I'm going to do less now. Let's see, 18 and 18 is 36, so I'm going to go ahead and just do those 2 times 18 equals 36. That gives me 72. So I did that 2 times there. I can do it again. 6, 3, 4, 5, 6. And I could do that one more time. 2 times 18 is again 36. And I have 0 left over. You might have seen a larger number you could have done 18 times before I did. I just didn't want to, like I said, calculate in my brain too much. I just wanted to get those numbers down fast. Put all these together, and that's your answer. So 10, 20, 30, 31, 32, 33, 34, 35, 36. No remainder is our answer using partial quotients. Takes a few minutes to understand what they're doing. Once you get it, you're just kind of taking it on down the road. Let's look at this next one. Same thing, we're doing partial products. So I'll do 62 times something until I've covered as much of that 3,186 as possible. So I'm going to do 62 times 10. That's 620. So I've used 10 so far. And subtract, and I get 2,566. I can certainly go some more. I'll go another 10. And that is, again, 620. 6 minus 2 is 4. And I've get a 9 there, 1,946. I can go again to get 620. So I've used another 10. Subtract. I can keep going. I might have wanted to try and look for something bigger, but it's going fast enough anyway. 706, so I use 10 again. I can do that one more time. 620, I get 6 left, and 8 left. That was another 10 used. And 62 is only going one more time. It cannot go twice there. So 4, 6, 7, 8, 24 is my remainder. And I know it's the remainder because it's smaller than my divisor. So I used, let me put this 1 here from right here. I used 10, 20, 30, 40, 51. 51 with a remainder of 24 as my final answer. Okay, last one. Feel free to try it. Just keep in mind if you try it and you use different numbers for your partial quotients than me, then we may have a different path to get there, but ideally we end up at the same answer. We should end up at the same answer regardless of which path we took, so you can go ahead and try it. I have 858 divided by 57. Let me go ahead and write it this way. 858 divided by 57. I'm going to use those tens. They are easiest for me. 57 times 10. So there's 110. I'll just, instead of writing them off to the side, I'm just going to underline them. That's 570. 8 there. I've got to borrow here. 8 there and 2 there. That's the only amount of tens I can do. I'm just going to start doing, I don't want to do 57 at a time. Well, it's 57 with another 57 is going to be 114. I'll do 2 times 57. That's 114. I'm right. I better check. I'm going to mess it up because that's 14, 10, 11. Yes, it is. Yes. Okay. 4, 8 is minus 1 is 7. 2 minus 1 is 1. I can fit that 114 again, so I'm going to do that 2 times 57 now that I know that that's what it equals. So 114 again. Leaves me with 60. That is still bigger than this, so I can do one more 57. And, oh, okay, yeah, 57. And 10, 3 left, remainder 3. So I ended up with 10, 11, 12, 13, 14, 15, remainder 3. And that's the answer I get on that one. I hope you got the same thing. Whether you went the same path I did or you partial product in a different way, we should still end up with the same answer. I hope I did an okay job of explaining what they're trying to get through here, or explaining how to solve using partial products. Good luck on Think Central.